Hello everyone, it's really great to be here. Thanks Jasmine for inviting me, and thank all of you for showing up at this early hour. I'm Henrike Lode, as Jasmine already said. And yeah, the reason that you're listening to me is that I'm a game designer with a passion for creating educational games. I got my master's degree in game design from the IT University in Copenhagen in Denmark in 2012. And for that thesis, I collaborated with two other students to create a design guideline on how to make good educational games that are actually fun to play and comparable to proper entertainment products. And together we created a prototype of this game called Machineers, which is also still my Twitter handle because for 4 years I didn't do anything else. So this is a good way to reach me. Yeah, Machineers is an educational puzzle adventure that teaches kids to think like a programmer. It has received 3 awards, has been showcased all over the world, launched on the App Store and Google Play, on Steam and on the Windows Store. And currently I'm working on a lesson plan so I can help educators use this game to teach their students programming. But that's really hard, so in case anyone has done this before, use the game to integrate it into your curriculum and wants to give me some input on that, please talk to me after this talk. I can kind of almost skip this slide because Marilyn did a really good job at explaining why we need coding. And since you're already here at the Festival of Computing, there's a good chance that you already think learning programming is pretty important. But I think this whole movement of teaching children to code from a very young age is a very sudden change that came about, and many of you might not have had a chance to fully wrap your head around it. So in the risks of preaching to the choir, here's my take on it. Everything around us is controlled by computers. Obviously our phones, PCs and laptops, but also our traffic system and voting systems, the entire internet, all communication across the globe, our finances and taxes. In fact, there's very few parts of our lives that are untouched by computer technology. And a lot of people don't quite understand how it works. It feels a bit like magic, and magic can be a little bit scary. And that's history repeating itself. Humanity was scared when newspapers were invented and said they turned everyone into zombies on their morning commute because they're just looking at their newspaper. Same happened when movies came along. People thought they were poisoning people's minds and leading them to be unable to tell fantasy and reality apart. And the same happened when the written word was invented. People who could read and write text were considered witches, but not in the Harry Potter style. They were persecuted. And we tend to let fear get the best of us, and fear because of a lack of understanding is not a good advisor. So here's a nice quote from Douglas Adams that I think helps explain this a little bit. He says, "I've come up with a set of rules that describe our reactions to technologies. Number 1, anything that is in the world when you're born is normal and ordinary and is just a natural part of the way the world works. Number 2, anything that's invented between when you're 15 and 35 is new and exciting and revolutionary, and you can probably get a career in it. Number 3, anything invented after you're 35 is against the natural order of things." And I think the age limit is a little bit more fluid in real life. My 74-year-old father has been pretty good with his Mac at all times and emails, and my sister, who's 37, has always been kind of scared of technology once she accidentally installed a virus on her company computer, and since then she won't touch anything anymore, and she's very reluctant to let her kids play games on my iPad. Condemning something because we don't understand it is a very dangerous thing. I think we have to stop being scared and start embracing computer science as part of our lives. Just like we need to be able to read and write, even though we might never end up writing a good book or something like that. We need to learn to read and write code to be able to be part of this world as it is right now. Now it's time for a little poll, making sure that everyone is awake. Please raise your hand if you have written code before. Even the tiniest bit counts. Nice. Raise your hand if you think that you're fairly proficient at coding and think that you generally get it. Okay, it's pretty good. So all of you that have tried, which is pretty much everyone, know that it is really hard. And those who haven't probably assume as much. The mere thought of it can be terrifying. And it's it's basically all the rules of what we used to know are off in this case. Computer science doesn't necessarily make sense. This is the only science that was created by humans. And somebody decided a lot of these things in the 60s when we had no idea how far this was going to go and what we're going to do with this. So there's a lot of abstract things happening that don't really have any relation to anything else in life, and obviously it makes it very hard to understand. And we have this fallacy that we think we communicate clearly. Humans always think, I express something and it's very obvious what I mean, and everyone's supposed to be able to get it. But we don't. We're not nearly as good as communicating as we think we are, and computers show us that really harshly. You're giving the computer a command, and it's supposed to execute it, but it does something else. But the computer is not disagreeing or interpreting what you're saying. It's really doing what you're saying. So you actually have to go back and think about the way you were thinking of how you were expressing that. Another really weird thing about programming is that the people who are really good at it are really bad at teaching. Not as a teacher per se, but in order to really get far with programming, you have to understand it in such a depth that everything you learn in the beginning, you have to forget. You have to take it for granted. You can't memorize, unless you have a photographic memory, you can't possibly keep all the rules and all the small little things and how certain things are built up in your head at the same time. At some point, you have to take things for granted and say, this is just the way things are, so you can move on. And it keeps happening. So everything that comes from the beginning kind of falls as like, that's the way it is. It's like gravity, right? Why do I have to explain gravity to anyone? That is actually leads to the thing that people who just learned something are actually the best teachers. So it's basically the student in your class that has just understood how this works, because they understand why the other kids don't know. They just made that transition from not knowing to knowing. So they actually much better teachers than anyone else. And in the end, when you learn programming, no one is actually teaching. It's a stupid machine that you're communicating with. It just processes ones and zeros. It turns power on and off. That's the language it understands. It's basically you just going back and forth, trying to communicate clearly with the machine and trying to make it do your will. Another thing is that we really set a lot of times on using memorization, or like checking up on if somebody learned something by checking if they memorized the fact. And that doesn't really work with computer science. The computer stores the information for us. We can look it up. It's saved in a certain place. Using our energy to memorize certain facts is unless you have a photographic memory, completely useless. You need to be able to look up the information somewhere, and it's okay. You don't need to remember everything by heart. You need to talk to each other, communicate, look stuff up on the internet, find solutions, and we have to share this information. And it's not about the mere fact of memorization is not a good way of measuring if somebody is good at something in terms of programming. Yes, I think I've said everything too. Why is coding hard to learn? All right, so what's special about games that is superior to teaching? Are games the better teachers? What's really awesome about games is that they get kids to do things voluntarily that most parents and teachers only dream of making them do by promising chocolate and candy. They sit still for hours. They focus. They listen. They remember what they hear and see. They deeply care. They seek additional information in all kinds of places. They form communities. They share their passion and information. They educate each other. They develop opinions and argue for them. They're having analytical discussions. They learn because they want to. And games let children pretend to be someone else, take on any new role without any real-life consequences. If they fail at a task, they can try again and again and again until they get it right. And none of these failures hurt as much as giving the wrong answer when a teacher asks, or if giving the wrong answer during a test, or being laughed at for saying something stupid in class. In big classes, children often don't really get enough individual attention, And if they process information differently and prefer to learn in a maybe more visual or more tactile way than the majority of the class, the same task seems more challenging for them, and they might feel inferior, fall behind, and then eventually stop working hard on it because it's just reinforcing them feeling bad about themselves. In fact, they might be smart enough to get it. They're just not getting the right way of interacting with the subject. The game lets the player practice exactly the right amount of times until they get it in their own pace. Gives them the freedom to experiment, to do silly things, to find secret ways of cheating, find better, faster, funnier solutions, and allows players to fail without shaming them. If I fail, it's not that bad because it's just a game. But when I get it right, I'm the smartest person alive, and I'm much more inclined to believe that I can do the same in real life. There's a lot of great programming games out there, and each of them might have a different appeal to different groups. I recommend trying as many as possible of these because there's no one ultimate game that can solve all the educational problems. Every game focuses on different aspects of programming and visualizes things in a different way. So you may already know about a few of these, but I hope I can show you at least a couple of new games to try. This is Lego Mindstorms Fix the Factory. There's tons of games like that. It's probably one of the most common things that you've seen. This game features a humanoid robot fixing the factory where all the battery packs have been dropped in the wrong places. And it's the player's job to write instructions in these code blocks or these directional blocks to guide the robot to move to the right spot, pick up the misplaced batteries, and put them back into the right places. You can walk, turn, pick up stuff, drop stuff off, but it can only move based on the commands that the player puts in. This is a human resource machine. That's a similar thing, but a little more advanced. You might recognize this layout a little bit from scratch. You're literally writing code here, complete with loops and logic gates. You manipulate data. You even have a little memory space that's a grid drawn out on the floor. And I think that's a really cool example to try. It looks very nice. Then, of course, there's SpaceChem. In SpaceChem, the player commands two circular Waldos by laying out paths and instructions for them, and the Waldos follow the path and sequentially execute any instruction they come across. They can grab, drop, rotate, sync, bond, fuse, request input, or dispatch output. The Waldo's analog in computing is the processor, a hardware component that sequentially executes basic operations defined by machine code. Like processors, Waldos are the engines that drive the control flow of the SpaceChem factory. This is Hack and Slash, a game by Double Fine. It's a Legend of Zelda-style adventure that challenges you to solve problems by reprogramming the source code of the game itself. You're playing Alice, and you win not by defeating enemies through traditional combat, but by finding elegant solutions or ingenious ways to negotiate the world around you by altering the code that defines it. So you're manipulating variables in the game that allow you to slow down time, to change the way the characters move, and you can even hack into your own character to change how you look and behave. This is Glitch Space. It's a first-person 3D puzzle game. You're trapped in an abstract cyberspace world, and your way forward uses visual programming to edit environmental geometry. While unlocking key programming concepts along the way, you stretch, scale, rotate, manipulate, and create and explore a world of reprogrammable geometry as you discover your way home, ever distant on the horizon. That's the pitch from the website itself. And of course, you all know about this game and that it can teach programming. I haven't looked too much into this, but there's lots of different ways that you can use Minecraft to teach players code if they want to. And some of it is the redstone technology that's kind of mimicking electric circuits, as you can see in the images. But there's also extensive modding options that allow the player to change virtually everything in the game to their liking, giving the player the power to redesign the entire Minecraft world. And that's a great motivator for the kids. And this is Elle's Heartbreak, and I have not actually written down the description of the game itself, but you play in this very 80s set world. It's more of an adventure style thing where you can change the code, and like in this scenario they're changing the color of the light to solve certain puzzles. It's very cool. And of course, Machineers. That's the game I've been working on for the last 4 years. Educational puzzle adventure that teaches kids to think like programmers. The term is procedural literacy, the ability to read and write processes. And all these puzzle elements in there represent programming structures: switches, loops, counters, booleans, functions, all represented by mechanical objects that let the players know from everyday life, and they can make assumptions about this behavior. Like if it's a button, they obviously know I can touch the button and it will change between its two states. So yeah, it's encouraging them to explore and to experiment and make certain connections and see what happens. And then I'm working on a new game. It's called Octopies. It's very much at a concept stage. You play, your avatar is an octopus that is trying to make pies. But unfortunately, his tentacles are not very precise tools for baking, so he messes everything up. And instead, you have to program a food processor, write pseudocode recipes, and learn more about actually writing code. So I want to make a thing where they have to type, because the typing of code is really important to get there. And there's tons of other great examples out there, most of them probably similar in one way or another to the games that I've shown you. But if you know about any other educational game about programming that is radically different from the ones that I've mentioned and is super awesome, then please let me know. I want to check it out. So, if I let my kids play a bunch of programming games, will they become programmers? These are friends of mine. No, just letting them play games will not work. This is in a way like if you're trying to learn to speak, to read, or to play your first musical instrument. It will be hard, and you will never really stop learning. You always just keep improving, and the first year at least you kind of suck at it. That's the general rule of that. But to put yourself through that misery of feeling like an idiot most of the time, which programming is, you need a lot of inner strength, and you need motivation. And we know that the only real motivation that works comes from the inside. Kids need to use programming to create, and not necessarily anything serious. It doesn't have to be a database or a website, just for the heck of it, because it's fun. Like when they learn to speak, they babble, they make these cute, annoying baby curses. When they learn to draw, they make art, some gruesome, ugly, sometimes funny and silly. But you have to start somewhere, and it has to be okay if it doesn't work, if it looks bad, or if you as a parent or a teacher don't really get what they're doing. They have to set their own goals, get better at something that they care about. We all get excited about the idea that we can create something, and programming is very special because it allows you to create your own universes, anything you can imagine. So instead of forcing them to perform for someone else, I think we should let them play. Thank you.